Hello again. In this video we're going to learn about indirect derivation in the formal system. So we want to just make sure we know what a contradiction is to start with, and here are some examples in the formal system. So P and not P, negation P, that's a contradiction. Negation P and negation P, that's another contradiction. P and Q, negation P and Q is yet another contradiction. Whenever we have a sentence box and then box with a negation in front of it, the negation of box, we have a contradiction. And box can be complex. So in our first example, box is just P. But in the second and third examples, box is not atomic, it's complex. In the second example, box is negation P. In the third example, box is P and Q, the conjunction of P and Q. A contradiction cannot be true. One of the two sentences in the contradiction must be false. That's the important fact about contradictions that makes indirect derivation a valid way of establishing an argument. So, let's look at an example. So, let's have the argument we had in the English system, in English, was if I have a cookie, I will be happy. If I don't have a cookie, I will be happy, so I will be happy. So we can symbolize that as if R then Q, if not R then Q, therefore Q. And that's a valid argument, and we would like to do a derivation of it. So let's suppose we just proceeded as normal. So we write show Q, and then we think, well, can we make an assumption? Say, well, our only assumption is CD, and we're not trying to show a conditional, so assume CD doesn't apply. So the next step is just to enter our premises, which we would do. And then the next step would be to try to apply inference rules. Now we can apply double negation and conjunction or adjunction and addition, but none of those would be very helpful. And we can't do modus ponens because we don't have R and we don't have not R. And we can't do modus tollens because we don't have Q. And so if we proceed in this way, we'll just get stuck. There's nothing more to do. So far, before we add indirect derivation to our system, we cannot do a derivation of this argument. So what are we going to do? Well, we do it differently. So again, we'll start with show Q, but then we'll make an indirect assumption. And if you'll remember from the example in English, we said I want to establish the conclusion of the argument is I will be happy. And so we supposed I won't be happy. We supposed the opposite of the conclusion. And that's what we'll do here as well. We'll suppose the negation of the conclusion. And so we say assume, but here we don't say CD, we say ID for indirect derivation. Having made this assumption, we'll now bring in our premises. So we'll say if R then Q, that's our first premise, and if not R then Q, that's our second premise. Now we want to look for inference rule applications, and now this is straightforward. We can apply modus tollens with 2 and 3 and 2 and 4 because the consequent of 3 and 4 is Q. For modus tollens, we need the negation of the consequent, we need negation Q, and that's what we have on line 2. So we'll say not R, and then we'll say not R. And note, by the way, actually, we could have also said 4 or 5 modus ponens and gotten Q. And that would have worked as well. But here we'll say, we'll do these 2 modus tollens applications, and we get not R and not R. Well, that's a contradiction because we have not R, and then we also have the negation of that, not R. So we have a sentence and its negation, and so we say 5, 6, which is the lines on which the contradiction are, indirect derivation, and we box and cancel. So that's an example of an indirect derivation. So the 2 new pieces are lines 2 and line 7. Line 2, we say assume ID, and that lets us write down the negation of the conclusion. And then once we get the contradiction, we say, with conditional derivation, we say here's the consequent. With direct derivation, we say here's the conclusion. With ID, we say here's the contradiction. Where's the contradiction? On lines 5 and 6, and so that's what we say. We say 5, 6, ID. So to write these rules out, for assume ID, well, you can write assume ID immediately after any show, but only immediately after any show, just like assume CD. So you can only make one assumption for each show line. You can't make both. If you have show box, you can write not box. If you have show not box, you can write either box or not box. So that's it. You say assume ID, and you get to write down those things. How do you box and cancel with ID? Well, suppose you have any contradiction whatsoever. For any sentence, it doesn't matter how it's related to the assumption or the conclusion. Any contradiction at all, you say you have circle on line M, and you have not circle on line N. So, I don't know, lines 5 and 7 or whatever. Then you say mn, so 5, 7, say id. So you write down the lines on which the contradictory sentences occur, and that will let you box and cancel the show line. And that's how it works. And just to be clear, to repeat something, the contradiction does not have to include the assumption. It didn't in our example, right? The assumption, the conclusion was Q. The assumption was not Q. The contradiction in our example was not R and not R. There's no Q in there at all. That's okay. No contradiction can be true, so if you can reason from the supposition plus the premises to any contradiction, then you know at least one of those has to be false. And that's how indirect derivation works, so that's all you need. So let's see what an indirect derivation looks like. The first line is show box, where box is the conclusion. Second line, we make an assumption, but it's not assume CD. We write not box, and the justification is assume ID. Then we proceed as we have been in the past. So we bring in our premises and apply our inference rules. And we keep going. And so let's say at some point we get not circle, but we keep going and we keep going. And at some point we'll then get circle. And we think, oh wait, that's contradiction. Now you have to be looking for that. Nothing in the system tells you you've got a contradiction. You just have to recognize, oh, at some point I got far enough and I got a contradiction. I have not circle and now I have circle. Maybe circle comes first, and you get not circle later. But in any case, at some point, you're chugging along, you think, I've got a contradiction. Good. And you immediately stop, and you say ID. You say 4, 6. Those are the lines on which the contradictory sentences occur. ID. So you have circle and not circle, whichever order, doesn't matter. And you say, here are the two lines on which they are, and then you write ID. So you have to write both of the lines, and you don't write the assumption line either. Just like with CD, you only write where the consequent is. With ID, you say here's where the contradiction is. And when you write ID and hit enter, you can box and cancel. You cancel the show line, you box the reasoning, and you're good to go. As with conditional derivations and even direct derivations, this can be done in a subderivation, but here we've seen it where it's the main derivation. Okay, so in the next video, I'm going to briefly review sort of some strategic points and how to proceed, and then I'll be doing examples of indirect derivations in the subsequent videos.